here to present some of the insights on three specific aspects: design, regulatory issues, and O&M support of nuclear power plants. So far, for the last 2 days, we have been talking broadly on how to bring in the nuclear power in this country, how to develop power more, different strategies. So that was all generally broad level discussion. What I've tried to combine here is some execution level differences that I have seen by virtue of my association with different designs, different nationalities. So these are the three specific topics, three areas that I found I could contribute, sharing my experiences with the general audience, as well as the people who want to know more insights about how the Indian nuclear sector would be working, and if they want to take away something from this while considering when to put the nuclear sector, nuclear power plant into the in India. So let's begin the presentation. I'll cover the first topic as design, and we'll see what are the prevalent design engineering practices that we follow in India. We all know that this is primarily design is mostly focused on the three-stage, to further the three-stage program, where we have the DSWRs, FBRs, and ASWRs subsequently in the third stage. This is the main focus areas as always. The light water designs, I would say they are not as matured as these three designs that we have available at this moment. Primarily the reactor, the fuel design, the NSSS components, all the primary side of nuclear is done in-house. When I say in-house, it is within the DAE. These are the different organizations involved for the development of this particular side of the nuclear. And we have got definitely comprehensive capabilities in terms of analysis, in terms of all the modeling and all of the techniques that is available in-house. So PSWRs, as we all know that, yes, this is anyways a mature design. The design is mostly ASME, so it's very popular in India to follow or to do the design on the ASME codes. So you will generally find that this is more in line with the ASME codes. The other part of I would say nuclear power plant, besides the primary side or the reactor building, we also have the capital equipment. We also have many package systems, chillers, compressors, and DGs, GIS. Those are typically OEM based, and those are package supplies. So that is how I think the more standardization could be achieved in this way. The other part is the project engineering or the detail engineering when we do. It is partly outsourced. When I say partly, generally the nuclear side of it is the engineering is done in-house. We have got all the capabilities there. When it comes to BOP, when it comes to TG, that area can be outsourced for the detail engineering. Even INC, instrumentation and controls part of it is mostly done in-house, because the design itself is available in-house. All the engineering programs and processes that we may see here, those all comply with the guidelines that are given by the 𝑵𝑖𝑚𝑣 INBP. However, the implementation of those programs, they largely differ from what you might find in, let's say, INBP and �Β𝑖𝑚𝑣 literature, because that is more aligned to the organizational structure that we have in the country, as well as the industrial practices that we follow for the nuclear industry in the country. So these are more aligned into those lines. The off-the-shelf items, I would say typically these are more used in the instrumentation and control area, so we will find the limited use of off-the-shelf items. in terms of software packages, in terms of so many other platforms, those will be typically limited, and especially in the safety and safety related area, the nuclear side of it. You'll find in the PSWRs, the reactor protection systems, regulating systems, all the control systems, they're all designed in-house, modeled in-house, manufactured in-house. So what we see in outside or generally in the other countries, that predominantly the design is centered around the light water reactors. So we'll find more of pressurized water reactors based on the light water design. That is what we'll see most of the Western world doing, most of the Europe and most of the, I think, Russia, China. Everybody is mostly focusing on, even Korea. It's mostly, you see the number of reactors, there are less of PSWRs, more of PWRs. And of course, PWRs. And the market is, we find that yes, it is more mature in terms of the number of suppliers, number of support agencies available in any nation. In India, we have got enough base, enough support as far as PSWR is concerned, but I'm just putting it out comparatively. Internationally, we have more players. You can find presence of more agencies in a single nation who are actually into the reactor design. You will find, for example, in Russia, you can find different another project as well as at 2 different places, and even Rosatom doing the design. So different countries will have multiple options available for different reactor designs. The project engineering, what I found is, along with the plant integration, will be fully outsourced. So yes, integration part in India, it is typically done in-house. You can have the entire project engineering broken up into different packages, but the integrator is always in-house. It is within 𝑑𝑖𝑁BCL. But in other countries, you can be an owner, but you can have different integrators. So plant integrators also, integration is also outsourced. It is a very common feature. And the capital equipment, I think that approach is same. That approach remains within India as well as abroad. We'll have OEMs, we'll have package suppliers, and those are taken advantage of. Amongst the other features that you might see, there is extensive use of the off-the-shelf products. So you can have a platform which is provided by, let's say, ABB. You can have a platform which is provided by Siemens. So these are off-the-shelf products available. You can deploy them into the nuclear safety-related area as well as non-safety. So they have the N-qualified items already available. You can just select those, put into your design, and plug and play. So that's a bigger advantage there. And all the engineering programs within the organization, you can see some of the examples like system health monitoring or equipment reliability or welding program or life cycle management. These are all well, I would say, laid out in terms of the guidelines given by the 𝐓𝐈𝐌𝐄𝐒𝐓𝐀. Not just the guidelines, but also the detailing is being provided by those agencies. And somehow the organizational structure, the function, the way the business is carried out within the organization is structured in such a way that it supports the implementation details available into those guidelines. And design codes and standards, those will be country specific. If you are in US, it's an ASME. If you're in France, it could be RCC. In Russia, it could be GAN standards, so those standards, PNAC. So all those different standards, those are country-wise. Korea can be Quebec codes. So yeah. With that, we come to the second part of it, regulatory aspects, probably some of the aspects that I'll be covering. You can relate those things to the discussions that has happened so far in last 2-3 presentations, particularly Dr. Srikanth's presentations. So we'll see why some of the points that were brought out in those presentations, you can find that at execution level, you can actually see those differences between India and the practices of the regulator worldwide. So licensing consenting is a multi-stage process. This has been already covered by Dr. Srikanth in earlier slides also, that it need not be a multi-stage project. But as of now, the regulations are designed in such a way that you have 5 stages. You have to go through each stage one by one, siting, and you have construction, you have commissioning, operation, and decommissioning. So the intent of this was at the siting stage to see the suitability of the plant and impact of plant on the environment and impact of the environment on the plant. And subsequently for other stages like construction, we do the design basis review, see the suitability of design, whether it is fit for that particular site. And at the commissioning stage, there is more like checking the as-built. So if whatever is committed during the design, if it is being implemented well, it has to be seen during the commissioning stage. And at operation stage, we will see the satisfactory commissioning, or you can say design validation. Whatever has been committed in design is actually being validated and fit to go. And that is where the operation consent comes in. And operation consent actually also will cover subsequently. It is a continuous process. It's not just happening one time. Multi-level safety review design. We have already seen that yes, there is a PDSC committee, there is ACPSR committee, and there is final approval given by the ERB. So yes, there are multiple tiers available. Even before PDSC, there are separate working groups. So you can say practically 4-tier system is there to review the suitability of design or the depth of the design. In this case, in particularly for India, the regulator will give you an operating license for 5 years. So it's not because it is a multi-stage program, it's not a 2-stage program like US where you have construction license, operating license given for the entire design life. So that is not the case. So in this case in India, you get operating license only for 5 years, and after 5 years, you have to undergo a limited scope of safety review. After the regulator is satisfied with that limited scope of safety review, the further extension of license is given. However, there is another stage called periodic safety review, which is a requirement as per the IAEA as well. It happens at every 10 years. This is the usual frequency, 10 years. Yes, it will. They will carry out a full scope. In India, it will be a full scope periodic safety review. All the 14 points as suggested by IAEA have to be covered and in depth. And yes, after the safety review, the further decision is taken to further grant the operating license or review. There is a slight different approach taken for imported reactors. However, again, the same point, one of the points brought up by Dr. Srikanth, that why the regulator has to go through the entire grind again when the other regulator has already done it. So in that, on those lines, the Indian regulator does a comprehensive review within the regulations and guidelines available at India, but at the same time, they also see what are the observations of the supplying country regulator and what are how those observations or the remarks were actually addressed by the supplier. So that is a mandatory exercise that we did in Kudankulam as well, and yeah, that was the first case example that I've seen reactor being imported and undergone the regulatory cycle. And it's important that Indian regulator will always require a reference plan to be specified. It cannot be a completely first of a kind. Only that is not acceptable yet in India. That a complete first of a kind design should be deployed for gaining experience. So yes, there is a mandatory requirement of a reference plant running somewhere in the world before it could be accepted. In Indian ARB system, there is no practice of having a generic design certification, just like in US and RC. You can give a broad design or design intent. You can present before detailing it, and you can get a generic design certification. That process is not, that system or practice is not there in Indian regulatory system. We have another this thing also. Regulators typically not involved in any of the equipment qualification. They are not involved in manufacturing QA/QC activities or QS activity, and they are also not doing any supply chain certification. But in certain countries, the example that I know is of Russian Federation, where actually all these things are actually done. The GAN, they are participating in the manufacturing QA/QC activities. They do the supply chain certification. They also do they are involved in the equipment qualification. Country to country, practices are different, and this is the way how it operates in Indian regulatory. Generally, there is no formal. This has been a recent development that there is no formal, typically, approval required. If you are in a license period, and if you are taking a plant shutdown for refueling or something, or biannual shutdown, then you don't really need to have a formal approval for restarting the plant. You may still submit the application, but that is just about it. It doesn't need any formal clearance or approval from the regulator. This is a interesting, I would say, point. The regulatory services are completely at no cost to utility. So that also means that utility cannot influence the regulator. That is one part of it. But that also could mean that there could be project overruns, because now the regulator may be more concerned about the review and safety review and the design part of it. They may not be very much concerned or directly linked with the project schedule. So that is the way the regulator works here. Let's see what we have otherwise in other countries, largely a two-step process. Now, most of the regulators are adopting this kind of a process suggested by US and RC originally, but I see that a lot of regulators in Europe also has adopted this. And this is a two-stage process where construction license is offered, operating license is offered. These are the only two stages. So at construction license, basically you should be ready with the PSR design basis, all the necessary details of design, so that you get a construction license. And at the operating stage, it will be, again, design validation will be there. There will also be check for the readiness of programs, processes, people, procedures, so policies. So they will see if everything is in place, then yes, you will be given an operating license for the entire design life of the reactor, not just 5 years or limited period. It will be there for the entire design life. Yeah, so we covered that license is applicable for the whole design life. Periodic safety review still is a requirement. It happens in other plants as well worldwide, but it depends on regulator if they want to do a full PSR or if they want to do a limited scope PSR. That purely depends on how the regulator does it. Generic design certification, yes, it is possible in these cases. Even if you don't have the details available, even if you don't have the intent to put a particular nuclear design at any particular site, you can still get the design approvals and design certifications in place. So that is kind of a preemptive, I would say, exercise that is done. We have seen that there could be a participation of regulator in equipment qualification, manufacturing, QA/QC, and other stuff. This again is a conditional thing, and approval may be required. Typically, it is required because over the period of 60 years, regulator cannot leave the utility go without any checks and balances. So, in most of the cases, there is a requirement of getting an approval before the startup, after the refueling or after a planned maintenance outage or anything like that. Yeah, this is a bigger difference. Regulatory services are at a cost, so they don't come free. So while utility is, or not the utility, the main designer is, conceptualizing a design or detailing a design, they will have to take into account the licensing cost, which is not there in the Indian context. And the third part that we want to see is O&M support, how the operations and maintenance are supported when the nuclear power is, power plant is actually operating. So some of the practices in India that we can see, I started with maintenance because I have been closely associated with the maintenance department recently. So just trying to find out, trying to put out what are the major differences. So in India, we have a maintenance department, typically will be responsible for all these varied tasks, planning for a maintenance, executing, making the procedures and doing the scheduling, and even providing the plan during the outage maintenance. So in a sense, if we see, these are very varied roles. The planning role is entirely different from execution role, entirely different from developing a procedure. So these are very varied roles that a maintenance person typically fulfills. And the team, whoever is assigned a particular system, assigned a particular area, they will have a full grip and knowledge about that system, because they are doing all the things like planning, execution, procedure making, everything by themselves. So they have a very inside-out knowledge in that sense about the assigned systems. Their area is assigned. In that area, in that focused area, they know each and everything about it. And the maintenance information is also under the control of maintenance group. So when I say maintenance information, what does it mean is, I'm specifically talking about the PM programs, PM bases. I'm specifically talking about the history records. These are all completely controlled by the maintenance. There is no, I would say, no participation from any other function in that sense. We also have the maintenance work execution is generally through reference documents. So whenever a person goes into the field, we will take the procedures, we will take the vendor manuals and necessary things, but they will all be meant for the reference use. So there is a difference between reference use of a procedure and continuous use of a procedure. When we say continuous use of a procedure, you have to go step by step as written in the procedure and execute the steps. And when we say reference use of the procedure use is left to the discretion of the executioner, because he has got necessary depth of skills, knowledge available, so that if he likes, he may refer the procedure or not. That is left up to him, depends on the difficulty level he faces at that time. Most of the routine maintenance is done in-house within the utility, within the plant, station, whatever we call it. And generally the OEM support is solicited in some of the special systems or special cases. If it is a bi-annual shutdown in case of PHWRs, the workload is pretty high. So at that point of time, we would like to have more hands on deck, maybe more support, and try to have more supervision. So that is why OEMs are typically more engaged at that point of time than the routine plant operation. The critical spares, they are all sourced either from OEMs or the authorized partners. And there are also periodic peer review meetings happening across the maintenance experts across the stations, I would say, across the sites, so that every year they get together, they try to share their learnings, try to improve systems at each station by this sharing of OEM lessons learned. And the interface with the external agencies is typically limited to one COG, that is Kandu Owners Group. So these are the prime two agencies with whom NPCL interacts, or at the moment any PSWR party will interact in India. It's only these two groups. The recruitment, the manpower we talked about yesterday is also an important part. How we can invite, or how we can create awareness so that there is more participation of the manpower. At the moment, we have a very established pipeline. Fresh graduates typically enter into the nuclear sector, and they gradually, I would say, progress through or promote through to the leadership level. The lateral entry is more or less not practiced widely in India. We'll see how. And this is an important aspect, governance and oversight. So this governance and oversight, there is no separate, there is a practice called corporate function area manager or management. Typically this is a practice followed in outside India, and you have a dedicated group which is available at the corporate office, who will look after the entire fleet of the reactors. So any issues concerning the entire fleet will be addressed to the CFAM group. This practice we have not seen in NPCL so far. The issues that are being faced on site, they are typically addressed within the site itself. Talking about operations, we have talked about maintenance so far. Talking about operations, the operation support to MCR. MCR is typically manned as per the minimum manpower requirements which are specified in the 𝐓𝐈𝐌𝐿𝐴 guidelines. And if there is any extra additional support required to support the MCR staff, then that is generally done through the general shift crew. It is available besides the round-the-clock shift. So those people are available as a general shift crew from 9 to 5, and they can support for any other operation. The operational support group also handles the activities related to permits, clearances, OTO, because the general shift is in itself is a qualified group to operate the power plant. So they can handle all these specific tasks which are very specific to the main control room. They can do the procedure development, and they also help the general shift to maintain the consumables. It could be purchase of certain sundry items, it could be purchase of, let's say, boron, or purchase of cotton, or any other stuff like that. So all the procurement stuff is taken care of by the general shift. When we see outside India the practices, we saw that, again coming back to the maintenance, the role, or one person has got multiple roles to fulfill in the maintenance department at Indian nuclear sector, but those roles are actually very well split out and cut out for the maintenance department outside. So you have different function available for doing the maintenance execution. Work in the field is done only by one particular department. Planning of the work, maintenance work is done completely for the entire plant. Now here it is not divided by the system, there is no assignment of the systems, but the entire task of planning or execution for the entire systems in the field is done by separate functions itself. So maintenance execution, talk about planning, talk about writing procedures. This is the job that my team does. Is a completely different function or team, not going to field to actually execute the work. The procurement is initiated by a different party. The outage management is done by a separately dedicated management group. So this is how the functions are laid out. Now, because there is separation of the functions, obviously you need more coordination to actually get the job done. So the requirement of the coordination increases there, and because the requirement of the coordination increases, there is also a requirement of automation that increases. So typically for doing the work scheduling, the optimization, it is the ERP systems are typically relied upon, and those systems are used intensively like SAP and all other stuff, so that the work can be planned and executed smoothly and closed out smoothly. We can also see a separate fix-it now team which only focuses on urgent and not complex kind of maintenance. It doesn't usually go to the regular maintenance department. There is a separate small group called fix-it now. They will take up any urgent issues raised by the operators, and that will be addressed. Here also, the OEM support is a common factor, generally preferred for maintenance and design changes and spare supplies. So typically, the association of OEMs in the cases outside India, we have seen that it is not only for the routine maintenance, but also for the design changes or the design upgrades. They also take up those functions or those activities in the system. To support the OEMs do that kind of a job, there are many prior MOUs or limited term contracts, agreements already available in place, so that all the conditions and everything is properly approved and accepted, agreed upon well beforehand. Whenever the requirement or the need for the OEM comes, they can straight away be called, and on the urgent basis they can do the job. This is a practice that we have seen in other countries for doing the maintenance. There is a work package filled completely, and this package is planned by the planning department, and then it is handed over to the execution people. They take this package into the field and actually do the job as written in the package. So this is the difference that we already talked, presence of CFAM to provide the governance and oversight in maintenance area and operation area. It is a common practice in other reactors. You would find that there is very intense, or not very intense, I would say very frequent interactions. Other than mono, there are frequent interactions with INBP, 𝐓𝐈. This is very, I would say, beneficial, because INBP, 𝐓𝐈, they have got a lot of, not just the operating experience and lessons learned captured into their system. They also help in terms of doing the R&D, doing the basic cost evaluations and all other stuff, so that you can improve the performance of the plant. So that kind of interaction is, at the moment, it is not there in Indian context, but yes, INBP and 𝐓𝐈, that can be very, very helpful in terms of interacting and getting the insights or the details of the of a complex problem. And the other activities on the operation side, the NCR operations are handled purely by the operation support group. That is, any activities other than the NCR operations. Just like in India, we have a general shift 2 available. There is a dedicated, separate, I would say, operation support group available, and who does all the necessary support to the MCR people. The manpower there is a slight difference. It can come through established pipeline to the fresh graduate program, but we have seen that there are two parallel lines of recruitment always available at any organization. It is one part is through the fresh graduates, another part is through the inviting the experienced manpower. So lateral entry is also possible, and most of the cases in the reactors abroad. So with these kind of differences and similarities, I thought maybe I'll just conclude and try to bring some of the points that could be, further considered. Maybe we can collectively, as a nuclear industry, we can reflect upon these points. What could be the strategies for growth and broader participation in nuclear ecosystem? Like, we know that there are less number of designers available, lesser number of suppliers available. So we need to think of some strategies. We have already discussed many during the past 2 days how the participation could be improved. So yeah, those can be some of the solutions, but this field is completely open in terms of what could be bettered upon. And certainly we need to come up with the strategies to how to faster the deployment of nuclear power plants in India, because the need is so high. We have recognized and we have realized in the last 2 days that yes, there is a faster deployment also needed. One of the points we already covered in the past presentation, that if there is a standardization of design, irrespective of the different environmental or the response factor conditions, then probably that could be one of the solutions where we can simply replicate the designs at any part of the country without going through a separate approval through the regulation. And we also need to see what kind of the strategies for closer engagement to actually harness the available experience, because typically we have seen after a person retires from the nuclear sector or leaves the nuclear sector, the know-how it's a cliff edge effect. The know-how is lost. So we have to think of some of the ways to actually capture this for eternity and keep the engagement open on a continuous basis, so that we kind of benefit from the available experience. And with that, I close my presentation. Any questions, they are welcome. Otherwise, for further discussions, I am available at this email ID.